Okay, so our lesson today is apply triangle sum properties. We start off by showing the different ways that we classify the triangles. We have the first set we're classifying by sides. So here we have the scalene triangle where we have no congruent sides. We have the isosceles triangle, which has at least two congruent sides. And we have the equilateral triangle, which is three congruent sides. One little note to make here on the isosceles triangle, notice it says at least two congruent sides. So you'll notice that the equilateral triangle does have at least two congruent sides. So the equilateral triangle is also an isosceles triangle. If you have any trouble remembering these, I have one little trick that I've kind of come up with over time that helps remember these. Usually don't have any problems remembering after this. So if you look at the first letter in the scalene, the isosceles, and the equilateral, the way to remember how many congruent sides you have is just looking at how many parallel lines you have, which would be helped if I could actually draw better here. But so the S, let me get my mark here. Okay, so the S, there are no congruent sides, and just no congruent sides. In the I, in isosceles, we have these two parallel lines here, two parallel lines. That's our two congruent sides. And then in the equilateral triangle, again, if I were drawing better here, we would have these three parallel lines, and that corresponds over here to our three congruent sides. So generally, once I pass that on, people don't have a hard time remembering that, so hopefully it helps. Okay, and then the second way to classify the triangles is by classifying by angles. Generally, you guys know these by now, but we'll go through them real quick. So we have the acute triangle down here. So these are three acute angles. And of course, the way that everybody remembers these is they are little cute angles. Okay, so the acute triangle. The right triangle, any triangle that has one right angle. So our right angle here. The obtuse triangle where you have one obtuse angle, so our greater than 90-degree angle here. And then we have our equiangular triangle, which is three congruent angles. So obviously, triangle has 180 degrees divided by 3. So whenever you have an equiangular triangle, each angle is going to be 60 degrees. Okay, so let me move down to our example here. Okay, so this one they are asking you to classify the triangle by the sides and angles. If you look here, let me get my little pointer here. It's a little hard to see. I find this a little difficult to see, but you have this side and you have this side that are congruent. So we know that that is an isosceles triangle. You can go in and measure it here, which is what they're asking you to do. When you do that, you'll find out that you have two angles that are 55 degrees and a third angle that is 70 degrees. So again, if you have three acute angles, then that is going to be an acute triangle. Okay, so for example 2 here, we are classifying a triangle that's in the coordinate plane. So for this, we're going to end up needing our distance formula, which I wrote for us again up here. So that's AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we go down, we have to do this for each of our sides, figure out what our side lengths are. So first we go in with the OP here, and we plug our information into the equation. So again, our x2 minus x1 squared, so that's our -1 here, and our 0 here, so we put those into the equation, and then our y2 and y1, so that's our 2 and our 0. So we put that in, we have our -1 minus 0, which is obviously -1 squared, which will be 1, plus 2 minus 0, which is 2, squared, which is 4. So we add those together, we get the square root of 5, which is converted to about 2.2. Okay, let me move the rest of this up here. Okay, so then for the second one, we're finding OQ. So that's this side right here. So this one, we plug in our numbers again. We have our 6 and our 0 that we plug in here. And then for our y values, we have our 3 and our 0. So again, we put them in. 6 squared will be 36, plus 3 squared, that's going to be 9. So square root of 45, that's about 6.7. Okay. And finally, we have side PQ. So this side here. Again, we get our x values, which are the 6 from here. And let's see here, where did I go? Okay, and the -1 over here. And then our y values, again, take our 3 here and our 2 here. Okay, so this will end up being 6 plus 1 squared. So that'll be 49. And then 3 minus 2, 1 squared will also be 1, so 49 plus 1, 50. And our square root of 50 is going to be about 7.1. Okay, so we have sides of 2.2, 6.7, and 7.1. So that means that we have a scalene triangle. None of our sides are congruent. Okay, then for the second part here, let me move this up here. Okay, the second part, we're checking for right angles. Actually, I'm going to try moving that down a little since it's going into my text. Okay, there we go. Okay, so we're checking for right angles, and obviously this is the one that we're wondering if that's going to be a right angle. The way that we can find out if this is a right angle is if these two lines are perpendicular. For perpendicular, we need the product of their slopes to be -1. So if we go in here, we find our slope for OP, so our y2 minus y1, again on OP here, is 2 minus 0. Our slope, our measurements for our x is -1 minus 0. So our slope here is -2. Okay, so let's go ahead and write that in. Okay, so our slope is -2. Okay, then we can come back to our other side here. This is our OQ. And we have, plugging again into the slope. So we have 3 minus 0 and 6 minus 0. So that ends up 3 over 6, and we can reduce that to 1/2. So let's go ahead and write in our 1/2. Okay. So then we come down and we can multiply together our -2 times 1/2. That gives us -1. That means that we have a perpendicular line, and also that means that we have a right angle here. So with that information, again, we set up here, this was scalene, this is right, so what we have is a right scalene triangle. Okay, so moving down the page, sorry, I don't really know how to get rid of this yet. I'll get better at this. Anyways, okay. What we've talked about so far mainly in this course, these are our 3 interior angles here. That's generally what we've been talking about when we refer to angles. We're also going to be talking about the exterior angles. So this is like if you extended the lines of the triangle here. So we extend these lines beyond what the actual triangle is. We have these little parts here Those are our exterior angles. Now, one thing to be careful of, you'll notice it doesn't include like this part, the vertical angle that of the interior angle of the triangle. So that's not included, that's not included, that's not included, just the blue part here, or the part that's included for the exterior angles. Moving down here. So we have a couple theorems here. So the first one, this one you guys know already. This is theorem 4.1, the triangle sum theorem. So it says the sum of the measures of the interior angles of a triangle is 180 degrees. Okay, so I think you guys know that already. So this is 180, and this is 180, 180 total. Okay, so we add those three together, we have 180. Okay, and our second theorem here with the triangles, this is the theorem 4.2, the exterior angle theorem. This one says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. And this one really makes perfect sense if you think about it, because like this is the angle that we're working with here. We know that the three angles of the triangle are going to add up to 180 degrees. We also know that this angle and this angle are forming a linear pair, so they're going to total 180 degrees. So it makes perfect sense that this angle is going to equal the sum of this angle and this angle. Okay, so let's move down to example 3, and we're going to do one of these problems here, where we're given our 2x minus 5 for our exterior angle. Our two non-adjacent angles are x and 70. So pretty straightforward way to solve this one. So at one side we have our 2x minus 5, our adjacent. Then we have our this was our linear pair angle here, our exterior angle. Okay, and our two non-adjacent here are 70 and x. So we do 70 plus x. You go ahead and simplify that, 2x minus x, that's going to give us x. We add our 5 from over here to the 70, and we have 75. Okay, and then if you wanted to find angle JKM, so that's this angle here, then we can plug back in our 75 that we had for x. So 2x minus 5, so our 2 times 75 minus 5, and that is going to give us 145 degrees. Okay, so our next vocabulary word here, or kind of term rather, would be corollary to a theorem. As you can see here, it's just a statement that can be proved easily using the theorem. I know that might seem like a few things that we've done already. There are some pretty straightforward, obvious descriptions, but anyways, that is the definition of corollary to a theorem. So this one here is corollary to the triangle sum theorem, and it states that the acute angles of a right triangle are complementary. So that makes sense again, because we know these three angles are going to add up to 180 degrees. We know the right angle is going to be 90 degrees. What we have left is 90 degrees. So yeah, it makes perfect sense that these are going to be 90. Okay, so we have our example 4 down here. And we have this nice little illustration over here. So it says the tilted staircase shown forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other, and we need to find the measure of each acute angle. And so this is a pretty straightforward problem here. So what you can do to solve this is to just sketch out your right triangle. So we said one angle is twice the other, so we have 2x and we have x. We already know this is 90, so these are going to total up to 90. So we have x plus 2x equals 90 degrees. That'll give us 3x equals 90, and then we can solve and get x equals 30. So the measure of the acute angles, this one is 30, this one is 60.